In this video, we'll explore one of the most famous things about honeybees, their venom. As will be typical for my channel, I will not talk much about the aspects of venom known to most people. Rather, I'll explain in everyday language the science of how venom works. Let's get started. Honeybee venom isn't composed of one thing. It's actually a cocktail of different compounds. These compounds contribute differentially to the pain, itching, and swelling you experience after a sting. The table to the right shows all the compounds in venom. Let's start with hyaluronidase. This is a protein, an enzyme actually, that breaks down hyaluronic acid. This is the glue holding your tissue together. Breaking down tissue allows the venom to penetrate deeper into your body. The next two compounds, phospholipase A and melittin, are maybe the most important parts of venom. They're definitely the most well understood scientifically. Melittin in particular has been studied by biochemists since the 1960s. All of our cells have a protective barrier around them made of a special kind of fatty substance called phospholipid. Both melittin and phospholipase break holes in this membrane. The holes in the membrane not only kill the cell, but all the stuff inside leaks out. This includes digestive enzymes that hurt the tissue around it, probably causing pain. Melittin makes up over 50% of venom, so poking holes in cells is the main way venom works. So far, we've reached this point in the table, about halfway through. Next up are the peptides. Peptide just means small protein, by the way. Most of these, like cecapin and apamin, are neurotoxins. Neurotoxins interfere with normal nerve function. Most of these are thought to cause pain, although the effects of bee neurotoxins are not well understood. MCD is a small protein that causes the release of histamine, which causes swelling. Histamine itself is also present in venom. Most of the other compounds in venom, including many still to be discovered, have unknown functions, although sometimes it is known what they do in other biological contexts. That's it for worker venom, but the story of venom is deeper, because it turns out queen venom is different from worker venom. First, you should know that the queen stinger is not barbed like the workers. The queen stinger is more like a smooth wasp stinger. This makes sense because the queen does not defend the nest. She has no need to give her life to save the colony, which is what a worker does after they sting and lose their stinger. The queen stinger, in contrast, is only used for fighting other queens. This leads to some interesting differences between worker and queen venom. First, queens have a lot of venom, at least when they're virgins. This table is from a paper that quantified the amount of venom in various honeybee castes and species. The top three are the Asian honeybees. They have venom in proportion to their size. For Western honeybees, they all more or less have the same amount of venom, although the Cape honeybee may have a little more. If you look at the queen data, you can see that a newly emerged queen has over 4 times the venom of a worker. She needs all that venom because she might have to fight 10 other virgin queens to inherit the nest after the swarm leaves. Needless to say, she couldn't do that if she lost her stinger after the first fight. Actually, that's not quite right. Even worker stingers don't usually come out when they sting other insects. The worker stinger is designed to get stuck in our mammalian skin, which has a denser structure relative to insect tissue. The queen emerges from her cell with her venom sac completely full. She is ready to go right from birth, which is good because she could be attacked at any point. Even before she leaves the cell. Many virgins are stung to death actually while still in their cell. The workers, in contrast, emerge with empty venom sacs. Their sacs fill with venom slowly as they mature. Queens not only have more venom than workers, but their venom is also different in composition. The venom of the queen is only about half as deadly to us as worker venom. Hence, you would have to get twice as many queen stings for the same effect you get from worker stings. Again, this makes sense because queens are not defending the nest against us or bears. They don't need the parts of venom that are useful for hurting mammals. Hence, hyaluronidase, which is useful for penetrating our dense skin, is lower in queen venom. There are, I'm sure, many other differences between queen and worker venom, but they are poorly worked out. In general, queen venom is probably optimized for killing insects. Finally, queens live a long time, but only need their venom for a few days. Not surprisingly, they don't maintain their venom, and it degrades over time. An old queen often has no functional venom left. Well, that's it for venom. I hope you found this interesting. If so, please spread the word about the channel. Also, like and subscribe. It helps the channel, and it will help me make more videos like this. See you next time.